waters of the Yangtze River in China rises the biggest concrete structure on the planet. The Three Gorges Dam is over 2 kilometers long and 60 stories tall. It has taken 40,000 workers over 17 years to build. When it fully comes online, this one dam will produce over 20,000 megawatts of power, twice as much as all the nuclear power stations in Britain put together. It is the pinnacle of dam engineering. China is one of the fastest growing economies on Earth. To fuel the need of its ever-accelerating industry, the nation needs more power. Much of this will be provided by an enormous dam spanning the mighty Yangtze River in central China, called the Three Gorges Dam. Our cameras have been granted privileged access to capture this amazing feat of engineering in its full glory. Before they could start building the Three Gorges Dam, the Chinese first had to divert the Yangtze River, which is almost 2 kilometers wide, and move over 1 million people from the area about to be flooded. And when they filled the reservoir behind the dam, the huge mass of water actually slowed down the speed of the Earth's rotation by a fraction.
Well, the Three Gorges Dam is the biggest hydroelectric project in the world. This dam used 28 million cubic meters of concrete. Maybe one way to look at it is to say it's a solid pipe of concrete, 1 meter diameter, right around the world. It's a lot of concrete.
But the Chinese authorities think it's worth the effort, as the Three Gorges Dam will provide clean and cheap electric power to millions of people. British engineer Robin Charlwood has been working on the dam since 2003 and is still impressed by its scale.
We're in one of the 3 very large powerhouses of the Three Gorges project. In this 700-meter-long room here, you can see 14 of the large turbine generators. Then beyond this one, a kilometer away is the second powerhouse, and then beyond that one is yet another powerhouse which will be underground in the rock on the far side of the river. Each one of these generators cost about $50 million, to give you an idea of the scale of this project.
Debden Dam had 1 generator. Three Gorges has 32. Together they produce 5 million times more power than Debden. To drive them, the Chinese have harnessed the power of the mighty Yangtze River. In the reservoir behind the dam, the river now rises up to 60 stories above the riverbed. The water is channeled down gigantic concrete tubes towards the generators. Here, the torrent of water hits the turbines and makes them spin. This motion is in turn transferred to the rotor of the generator. This is fitted with massive magnets, which move past copper coils in the casing to generate electricity. Just one of these machines makes as much electricity as a small nuclear power plant. All 32 generators together produce enough power for 60 million Chinese.
this project is setting a new benchmark in the international hydroelectric industry. It's almost twice the size of the next largest project, Itaipu in Brazil. And of course, it's only the first of a whole series of megadams that are under construction here in China.
The Yangtze River is over 6,000 kilometers long, and in places several kilometers wide, the biggest river in China. It presents enormous logistical challenges to the dam engineers. As the Yangtze rises behind the Three Gorges Dam, it will flood over 150,000 acres of land along its banks. So the Chinese have to relocate over 1 million people from the land behind the dam. Thousands of new houses have to be built for the displaced citizens to live in. Then the engineers can begin to dam the river.
We're standing here among some of the rocks and these precast concrete blocks that were used to create the cofferdams to control the river during the construction of the Three Gorges project. Controlling the river to allow the construction of this huge project was clearly a major undertaking. I mean, the Yangtze River is one of the largest rivers in the world, very fast, very deep. So building these cofferdams and to allow a safe construction was a major operation. The Chinese claimed that this was the largest and most difficult diversion ever undertaken for a hydroelectric project, and you look at the scale of it, they were absolutely right. This was huge.
The engineers begin work on a series of stone cofferdams to block off part of the Yangtze, whilst leaving a channel open for the rest of the river to flow through. They build the first two sections of the main dam on the dry riverbed. Then they dump tons of earth into the river, and on top of it build another cofferdam, this time from concrete. With the river held in check behind it, they can finally build the last section of the dam. Then they must remove the cofferdam so that water can flow through the turbines of the main dam.
Having built such substantial cofferdam structures, it's a major challenge how to remove these things. So in the earlier stages, where they were built of very large rocks like this, then that could be handled with big excavator equipment, relatively conventional. But in the final stage, where they had a solid concrete wall to remove, this required some serious innovation.
Unlike the cofferdam in Marej, the Chinese version is too tall to simply leave it in place. So the Chinese engineers build it leaving holes for explosive charges. On the 6th of June 2006, they filled them with 190 tons of dynamite and hold their breath. What has taken months to build takes only seconds to destroy. As the cofferdam crumbles, it unleashes the water stored behind it. It's the final test for the Three Gorges Dam, and it holds. The Three Gorges Dam takes concrete construction to new heights.
You look at it, you can just picture the thickness of the concrete at the base of the dam, the height of it, 180 meters, and it's 2 kilometers long. So it's a colossal amount of concrete.
Three Gorges uses 10 times more concrete than the Hoover Dam, so the engineers have to pull out all the stops to keep their dam cool.
They basically used everything in the book. They cooled the aggregates and the materials, the sands, before they put it into the mix. They added ice. They did everything they could to get the temperature down as low as they could before it started to warm up all by itself. And here, because of the issue of some of the summer weather being especially hot, July and August, they actually went so far as to use a fog spray system to blow effectively a fog blanket over the top of the dam, with the objective of blocking the solar radiation from piling down into the concrete and adding to the heat that was being generated on the inside.
But all these measures to stop concrete from cracking will count for nothing if the dam is built on weak foundations, as civil engineer Ed McCann explains.
While we can make the dam completely impermeable, it's rather harder for us to make the riverbed impermeable. Now, of course, once the water is up behind the dam here, there's a huge pressure pushing it this way, and whilst the dam won't let the water through, the water simply just goes underneath, and that means you haven't got much of a dam. There is a solution to this, and we'll, if John will give me a hand, we'll have a look at it. John, put the blocks, please. What you've got here is basically a pipe network. These are a series of vertical pipes that go down into the riverbed with little holes in the side of them. And we connect them up to a high-pressure pump. Of course, it wouldn't be this, but it would be a big pump. In this pump, what we've got is a watery grout. It's just cement and water. And when that cement and the grout goes hard, it creates an impermeable barrier. Just this time, it's in the soil. So we'll have a go. Here's our high-pressure pump. So if I squeeze that really hard, there we are. And pretty much straight away, you can see the grout coming out and running through the soil and spreading out, which is exactly what we want to see, of course. And you can see in some areas it goes a long way, and in other areas it doesn't get through. That means that the soil is denser and less permeable there. But that's fine, because what you do is you drill more holes down into the areas here, and you squirt more grout in, and you keep going until you've got a continuous curtain underneath the dam. And there we are. So we have our impermeable dam on top of the riverbed, and we've created a concrete dam underneath the riverbed.
To create an impermeable concrete curtain beneath the Three Gorges Dam, engineers drive 100 kilometers of tubing down into the granite bedrock. Then they pump 200,000 cubic meters of grout into the tubes, which is squeezed into the fissures in the rock. As the grout hardens, it turns the leaky rock into a solid waterproof base for their dam. Now the Chinese engineers can be confident that the Yangtze will not undermine their dam.
Basically, the dam holds back a large volume of the water during the flood period. Here it can hold back about 22 billion cubic meters of water. And then it's released in a controlled way through this system of 46 spillway gates and these chutes that you can see below me here. The design of a spillway like this has to deal with the force of the water as it drops over 100 meters in this case here, and then achieves huge velocity at the bottom of the dam.
To deflect the force of the water crashing down, the Chinese use technology similar to the Grand Coulee. As the water levels rise, engineers open a series of gates to drain the floodwater from the reservoir. But if the water fell straight down, it could undermine the foundations of the dam. So the engineers fit the spillway with concrete chutes. Unlike the Grand Coulee ramp, which is underwater, the Three Gorges chutes hurl the water into the air. Once airborne, the water breaks up into small droplets and loses much of its destructive energy. It lands over 100 meters downstream, where it can't do any damage. So now when they open their spillway gates, the Chinese have nothing to worry about. At China's Three Gorges Dam, the engineers also face a major traffic problem. Their dam sits on one of the busiest rivers in Asia.
The Yangtze is a really important waterway for navigation traffic in China, leading all the way from Shanghai, the coast, up to Yicheng, all the way to Chongqing. It's been carrying about 18 million tons of freight per year.
Getting about 170 ships a day over a dam that's more than 100 meters high is a tall order for the engineers. Befitting the biggest dam on Earth, the Chinese solve it by building the biggest ship lock on Earth. Ships enter the lock at the bottom of the dam. The gates close, water floods in and lifts the ships up to the next lock. Ships must go through 5 tiers of locks to get to the top, which can take up to 4 hours. This is fine for cargo ships, but for the many passenger boats operating on the Yangtze, it's just too slow.
To provide a more efficient transit opportunity for passenger traffic, they've built this ship lift system here, which will allow boats to go through in about 36 minutes.
Unlike the ship lift at Krasnoyarsk, the one at the Three Gorges will lift ships straight up, like an elevator. And the secret of its success will lie hidden in its concrete walls. The engineers will fit a series of massive counterweights that will do most of the lifting. Sixteen 1,000-ton concrete blocks will be connected by cables to the steel trough that will carry the ship and the water it floats in. As the counterweights drop, they will hoist the trough upwards and lift the ship to the top.
This ship lift here is 113 meters high and can handle vessels up to 3,000 tons. It'll make it the largest in the world and twice the size of the one at Krasnoyarsk. Certainly when you look at the structure now, it's got a ways to go in terms of construction. It won't be finished till 2015, but it's clearly huge. It's another very impressive achievement underway here.
The Three Gorges Dam produces more power than any other, but that's not the main reason it was built.
The Yangtze River is notorious for its really severe flooding. Over the last 2,000 years, there's been about one major flood every 10 years. In 1931, there was a really bad one, killed about 135,000 people, destroyed almost 2 million homes. And so this is the main reason why they've built the Three Gorges Dam, is to control this terrible flooding problem.
The dam blocks the path of the destructive floodwater. The water is stored in its reservoir and is then released in a controlled way. But managing floodwater can also have serious environmental side effects, as recent history has shown. In 1970, Egyptian engineers built the Aswan High Dam across the River Nile to control flooding. But soon, farmers downstream noticed that their harvests are beginning to fail. Their soil becomes so barren that the farmers need millions of tons of fertilizer every year to nourish their crops. Their land has suffered because it has been deprived of floodwater, which carries with it the vital building blocks of life. Chemist Dr. Andrew Shidlow demonstrates.
So we have here our clean rainwater, which has been falling. We're adding to it some good quality topsoil. We then add some animal excrements. We have some snail shells, essentially made of calcium carbonate. Then we have some dried leaves, plant vegetation here, and of course fish. As the storm proceeds, as the water starts to flow rapidly, all of these ingredients get mashed up in the hugely violent storm waters which occur. So here we have it, a veritable cocktail of Mother Nature's most important plant nutrients: nitrogen, phosphorus, calcium, magnesium, and potassium.
But if floodwater stops flowing, these nutritious particles of silt will begin to settle. This is a big problem, especially at the biggest dam in the world. The flow of precious Yangtze silt is blocked by the dam and trapped in the slow-moving water of the reservoir. It rapidly sinks to the bottom where it builds up.
The silting problem on the Yangtze is a huge problem. The total amount coming down is about 500 million tons per year, which equates to about 1 kilometer cube. Perhaps enough to fill big sports stadiums hundreds of times. It's a huge amount of silt.
If this silt remains trapped behind the dam, it would mean that farmers, fishermen, and wildlife would be deprived of nutrients in the water for hundreds of miles downstream. And the tons of settled silt or sediment could build up in the reservoir and threaten the dam itself.
Basically, sediment falling into the reservoir here would reduce the capacity, the reservoir capacity, and would eventually perhaps interfere with the ability to run the turbines if it came up that high.
Cleverly, the Chinese engineers exploit the power of floodwater to flush the sediment out of the reservoir and send it downstream. They installed sluice gates deep inside the dam. Each gate weighs as much as a bus and needs a powerful hydraulic piston to lift it up. When the operators open the gates, floodwater rushes over the trapped sediment and sweeps it through the dam. This way, the Chinese authorities hope that it will be at least another 100 years before the buildup of sediment affects power production at the dam. But even the clever purging system cannot carry all the sediment across the dam. Scientific estimates on how much sediment remains behind vary from as little as 30% to as much as 60%. But the Chinese authorities believe that this is a price worth paying. They are convinced that the benefits of the dam, such as clean energy and flood control, far outweigh its significant drawbacks. As the Three Gorges project draws to completion, its scale is breathtaking. Even with some of its turbines still to be switched on, it produces more power than any other dam in the world. Standing on the shoulders of historic engineering giants, the Three Gorges really is the ultimate hydroelectric dam. Until someone builds an even bigger one.